Okay, so you need to do a set theory and predicate calculus proof. So you need to first translate all these into predicate calculus. So when we have a subset, remember that that was the implication operator. So when I say P is a subset of Q, that means for every element of P, if X is an element of P, then it is an element of Q. So line 1 is for all X is in P implies X is in Q. You could also define that X is in P equals P of X, and in fact, even if you don't write that, I'll assume that's what you mean if you write P of X. So probably what I would do is write it like that. The second one says for all X, Q of X implies S of X and T of X. Remember that an intersection is a little and underneath. The third one is for all X, S of X implies R of X or T of X. So not T of X because it's in the complement. And the last one is there exists an X1 so that X1 is in P. So those are all given. And you will get some points for doing the conversion of the set theory into the predicate calculus. Yes? Yes, we do. 2 and 3, we should put some parentheses. Thank you, that was a good question. Now, when you're doing a set theory proof, you should not combine there exists with for alls until absolutely necessary. The reason is, as we've seen in our truth table proofs before, that we can't combine there exists unless we absolutely know that the same thing is the thing we're talking about. Remember that we said that if there exists a blonde person and if there exists a blue-eyed person, that does not mean that there's a blue-eyed blonde person. So if I get 2 there exists, I'm not absolutely sure that I can combine them together. So remember that every line in a proof is anded together. So I can combine all these for alls all day and still keep for alls. But as soon as I introduce anything with that there exists, I'm not going to be able to just do anything I want. I have to think about whether I can combine things. So what you should do is figure out how can I figure out that I want to prove actually there exists X1 so that R is in X1 is in R. Okay, so it looks like I could do hypothetical syllogism with lines 1 and 2. And I did put parentheses around there. And we've got an S and a T on line 3. I can't use hypothetical syllogism because the left-hand side doesn't match the right-hand side. So what I could do is switch the implication inside line 3 into an or. And then rearrange to get the S and T together. And this is just commutative. And then I want to switch it back into an implication so I can do hypothetical syllogism, but I'm going to first use De Morgan's to put these together to get S of X and T of X with what outside? A not. And once I have that, that looks like suspiciously like an implication. And once I have S of X and T of X, I can get for all X, Q of X implies R of X because that S of X and T of X overlaps. And then, did I have anything else? Oh, I wanted to use that. Thank you. So I should use 5 and 9 and hypothetical syllogism. And then 11, I'm going to now combine it with 4 to get there exists X1, r of x1. And that is modus ponens. Now, if you want to start with this one, it's totally fine. Just make sure that you are realizing that every time you use it there exists, you're actually talking about the one that makes line 4 true. So there's another faster way to do this proof if you do that. Questions on this one? So this is just like your old proofs. You'll lose approximately 4 points if you don't use predicate calculus. So if you just put like Q implies R and stuff like that, and there's no X's and there are no for alls, you'll lose about 1/3 of the points. You may choose to do that. I know you're all optimizing your own grade. You have to decide which grade you want to get and how much work you're going to do for it.